Welcome, ladies and gentlemen, to the session Nanotechnologies for Energy. The session will be devoted to the possibilities of nanotechnologies in energy, in particular towards higher efficiencies, lower costs, and the new market possibilities. This is a nice map showing the light on the Earth's surface during nighttime. And it is a collage of different photographs taken at different nighttime on the land. And as you can see, it is only to show you how diffused is the need of power supply, in particular for light, and in particular, obviously, in developed countries, even if, as everyone knows, this demand is continuously increasing. The possibility of energy conversion are briefly summarized in this sketch, and I show you this scheme only to remind you that the biggest part of energy conversion is actually due to coal, petroleum, natural gas, and nuclear. In any case, generation of electricity from coal and gases is cheap and with a lot of problems related to pollution and to the availability of resources. For this reason, there is an increasing interest in renewable energies, such as wind, biomass, sun, geothermal, and hydroelectric, and the very appealing side of the sun is that every day we can receive 100,000 terawatt, and this makes photovoltaics conversion very appealing in the field of the renewable energy. The requirement of the market in the photovoltaics field is, as has been decided by the European Commission, to reach grid parity by 2015, and that is to reach a price which can be comparable to the retail price of electricity, at least for small consumers, and at least in the Southern Europe countries. Furthermore, I should like to remember that over 50% of all power is used in buildings, and so strong requirements are now increasing for the so-called building integrated photovoltaics. Society is being more urbanized, and there is a need to integrate in the building the solar modules. Also, another need is towards portable power. We need to reduce dependence on the primary batteries, and in this field, flexible devices should be desirable for the safety, for the reduced weight, and the possibility of transport. In portable power devices, durability has not to be so high. We don't need a battery with a time life of 20 years. Actually, the photovoltaic situation is characterized by 3 generations of solar cell. The first one in this plot is reported to have a high cost in dollars per square meters and a relatively good efficiency, even if it is under the Shockley-Queisser limit. The first generation is silicon-based, crystalline and monocrystalline and polycrystalline silicon-based solar cells, and it has been interested, but a new generation, the so-called second one, thin film based, has appeared on the market, and it is now able to furnish solar cells with lower costs and efficiency only a little bit lower than the ones of the first generation. The third generation is the promise. it should be able to overcome the Shockley quasar limit, which is due to the single crystal possibility of obtaining energy, electrons from the sun. And it has generally been divided into the first kind, which is due to cells with very high efficiency and not very reduced cost. And in the third generation B, devices with moderate efficiencies but very reduced cost. The negative aspects of first and second generation are well known. Silicon, even if actually the biggest part of the market is governed by first generation, silicon uses large amounts of energy to refine and purify, is very expensive, the resources and the availability is not infinite, the price is now up to $3 per peak watt, and also the second generation is not sufficient to reduce costs and to guarantee the strong reduction in costs which is expected. So new concepts in photovoltaics are towards a higher efficiency, and this is the third B generation of solar cells that high efficiency can be reached by means of a band engineering, by multi-junction solar cells, multiple exciton generation, and some nano-architectures such as quantum dots and superlattices, or up and down conversion, and also plasmonics now. Lower costs can be reached with a different approach, which is by means of organic materials or printing economic techniques, such as for titanium oxide-based dye-sensitized solar cells. And new interesting market possibilities are opened by flexible solar cells, building integrated photovoltaics, applied also to some elements like ceramics. This is a very optimistic forecast given by Mark Grätzel in the conference of St. Gallen, and it is, as you see, we can expect that by 2030, the new concepts, the third generation solar cell, will be as high as the thin film, and they will overcome the production in gigawatt by crystalline silicon. Obviously, this is only a very optimistic forecast. In fact, if you look at the strategic research agenda of the European Union, it is clearly written that no technological winner or loser can yet be identified. So the question we will try to answer today in this session is, what can nanotechnologies do in this game, which is game is over. We don't have yet defined winners or losers. And the answer is that nanotechnologies can do a lot. If I want not take time, and my colleagues, the speakers will describe what they are doing in the nanotechnology field for incrementing efficiency and lowering costs in photovoltaic generation. For instance, new concepts are in quantum dot fields, the new cell, a tandem cell, all silicon-based, with the interesting possibility of using the silicon technologies to obtain a tandem solar cell in quantum dot, or the possibility of using nanostructured materials such as titanium dioxide in the dye-sensitized solar cells, or this is only the sketch for showing you how the dye-sensitized solar cell is working on a completely new concept with respect to the traditional p-n junction in silicon-based cells. Or also, for instance, nanotechnologies for photovoltaic devices not devoted to obtain electrons, but only to produce hydrogen for water. This is a project in which titanium dioxide nanostructured or nanotubes can provide the membrane in a reactor which is obtaining hydrogen from water. So, to conclude, I want to show you the Department of Energy of the United States, which has planned in 2007. It was still in the Bush administration. Now Obama will start with a new program, and even if it is not yet known, in 2007, the United States devoted $21.7 million in future generation solar cell, and in a very different fields, all involving nanotechnologies. So the answer to the question is that recent progress in nanotechnologies, quantum application and material science can really make possible fabrication of new generation solar cells, even if the market possibilities have to be explored. In this session, we will have 4 interesting talks. The one will be given by Maurizio Cossi from University of the Study of Piemonte Orientale, and he will speak us about a new generation of solar cells based on excitonic processes. Second, Dr. Nazeruddin from the École Polytechnique Fédérale de Lausanne will speak about molecular engineering of material for solar energy conversion. And Dr. Roberto Dolci from System Group will describe innovating ceramics for interesting application in building integrated photovoltaics. Finally, if Luca Sassoli will arrive from FinService, we will have an overview on the energy efficiency in the companies. I ask you to keep the question for the discussion at the end of the 3 talks. Thank you.